In this question, what is asked? A proton, a deuterium nucleus, and an alpha particle enters into a magnetic field with the same momenta. Find the ratio of their radii. One is we should know about the radii and we should know about the particle. So first, proton. Let us assume mass of the proton is mp and charge of the proton, it is opposite to electron, so it is E. Then it is deuterium nucleus. So deuterium nucleus is a heavy hydrogen. So there will be one proton and one neutron. So mass of the deuterium nucleus is actually, neutron and proton are almost having the same mass. So almost 2 times mass of the proton. Whereas charge of the deuterium nucleus is, there is only one proton. So like proton charge E means deuterium nucleus is also having the charge E. Then an alpha particle. So what is an alpha particle? So the alpha particle is the nuclei of helium atom. So it is, there will be 2 protons and 2 neutrons. So mass of the alpha particle is almost 4 times the mass of the proton, because proton and neutron are almost having the same mass. So assuming that 4 times the mass of the, and charge of the alpha particle is actually equal to only 2 protons. So 1 proton we took here to be E. So 2 protons, it is 2E. So these are the important facts about these charges. Now we are supposed to find out the radius of the charged particle in the magnetic field, because when these charged particles enter, they describe circle. We are supposed to find the radius. So radius of the proton first. So here what is given? Momenta is given. So we already know that radius of the charged particle is either mv by bq or root over 2m into kinetic energy by bq or root over 2mv divided by b square q. If voltage across which particles accelerated, if kinetic energy across, kinetic energy of the particles, mv is the momentum peak. So radius of the charged particle can be written as momentum of the charged particle by bq. Here all the charged particles are having the same momenta, only the charges. So radius of the proton is momentum of the proton by b times charge of the proton. Radius of the deuterium nucleus is momentum of the deuterium nucleus, which is also the same p, same magnetic field they are entering, charge into, b into charge of the deuterium nucleus. Radius of the alpha particle is p, because all three are having the same momentum, b into charge of the alpha particle. So r proton is to r deuteron is to r alpha particle is p by b into qp is to p by b into qd is to p by b into q alpha. All of them are same. So momenta are same magnetic field they are entering. So the net result is 1 by charge of the proton is E is to 1 by charge of the deuterium is also E is to 1 by charge of the alpha particle is 2E. So again the common things E cancelled. So we have got the ratio 1 is to 1 by 2. Multiplying the whole thing by 2, you got 2 is to 1. Suppose if they ask what is the ratio, what is the ratio of the radii of proton and deuterium, since they have the same momentum, you look at this way. So radius of the proton is equal to momentum by b into charge. So radius is inversely proportional to charge. P and B are same. So you don't need to go through the entire process. We just have to do like this. So radius, whatever common are, you just leave. Just radius is inversely proportional to charge. So R1 is to R2 is to R3 means 1 by Q proton. 1 by Q proton is to 1 by Q deuteron is to 1 by Q alpha particle. In one step you can take. So you don't have to write these many steps. You just can do it in one step. If they ask what is the ratio of the proton and charged particle, deuteron, they both have the same charge, then the ratio of the radii is 1:1 if their momenta are same. Okay. So the next part of this problem, if they all have the same kinetic energy, what is the thing we will see. Okay.